Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture, I am going to discuss about the critical thinking question discussion on logical agent. This is the course outcome. After the completion of the course, students can discuss the appropriate search strategies and knowledge representation techniques to implement inference mechanisms for AI-based problem solving. Now let me discuss what is the critical thinking question. Already I have discussed in my previous video also. Here we are not solving the complete problem. We are trying to test the critical thought process of a student, how far the student can think or student can analyze to solve this problem. So that is why the topic I have mentioned as critical thinking question discussion on logical agent. I think you might have known what is logical agent. Logical agent, it is a agent, or it may be even you can consider yourself as an agent or the physical agent, or you can consider the robot who can perceive the information from the environment, who can analyze or reason about the situation based upon the information gathered from the environment, and it can take the decision or it can perform the action to the environment with the help of actuators. Through the sensors it receives, through the actuators it can perform the action, and through the control system or the CPU it can understand or it can reason about the environment. So that is what is called as the logical agent. Now the question is given as, imagine you are creating a logical agent for an intelligent tutoring system that helps students learn mathematics. The agent must guide the students through problem solving by applying the rules of mathematics. Build the agent's reasoning process. Yes, this is the question. Here the question starts. We have to build the agent's reasoning process, detailing how it will represent the mathematical concepts and apply the logical inference, means how it can get the answer to suggest the next step in the problem solving. So explain how the agent will update its knowledge, also the knowledge base, its knowledge base based on students' input. So we have, so the overall this question says that we are creating one logical agent for intelligent tutoring system which can help the students to learn mathematics. Then how? Now, and this question is, as it is related to the logical agent, first of all, we have to build the knowledge which will have the knowledge of mathematics, so that that agent can teach to the mathematics, even it can help the students to solve the mathematical problem. Then how the agent can understand about the concept. If any question is given by the student, then how it can be reasoned by the agent, that we need to take care. And that is why it is given that agent's reasoning process, how the agent can give the answer, means agent's logical inference technique, and how the agent can update its knowledge base based upon the student input. So these are the things I have given based upon based upon the logical agent. And as this particular topic is related to the knowledge representation, in our module 2 it is there. So already I have discussed what is knowledge, why the knowledge is required for artificial intelligence, how the knowledge can be represented inside the machine so that machine can be intelligent and smart. Even any question we ask, a machine can able to reason, it can understand, it can infer the output in a better way. So all these things already I have discussed in my previous videos. If you want, you can go through those videos, then you come to this video so that you can understand the concept. So here let me find out the solution, let me analyze. So the problem is given that designing a logical system for math tutoring system. So the goal of this problem is to build a logical agent which can guide the students through arithmetic problems, applies the rules of mathematics using inference, and learns from students' inputs and updates his reasoning. These are the three things we need to consider while designing the logical agent or the machine. First of all, the machine should teach or machine should guide the students through arithmetic operations. Arithmetic means like addition, subtraction. I want to add 2 plus 3. We know 2 plus 3 is 5, but how if a student doesn't know how to add 2 plus 3, how is machine can help the student to add two numbers. So that is called guiding the student through arithmetic operations. So means all the arithmetic operations formulas we have to feed into the machine and applies the rules of arithmetic using inference. Means while adding the numbers, it is not every time like 2 numbers we will add. It may be 5 numbers, it may be 10 numbers. Sometimes we will apply the associative rule or distributive rule or commutative rule depending upon the arithmetic operation. So all the logical rules also we will apply or we will provide to the machine, so that machine can understand based upon the student's input and learns from student's input and updates his reasoning. At the next time, if the student gives some other input, not the exact input which is given inside the system, some other input, so how the machine can understand. So machine should be configured with AI, artificial intelligence and machine learning algorithms, so that it can learn from the student's input and it will be adapted to the situation and it will try to update the knowledge inside the knowledge base. So that is the goal of this problem. So the first step is representing the mathematical knowledge. So here we can use the first order logic, which is called as the predicate logic or the rule based knowledge, to represent the core mathematical rules. First, we have to create the knowledge base. Knowledge base means where the knowledge of the expert will be stored. As the problem is related to the mathematics and it should handle the arithmetic operations. So all these operations we have to write in the form of first order logic, okay, or the predicate logic. So here I have given some example. I hope you can understand. Rules in the knowledge base. The first rule is addition identity. Anything you add with any variable, like 0, if it is added to any variable, then the answer would be the same. X plus 0 is X. But in using the predicate logic, how we can write? So for all X plus 0, that would be X. Okay. So X may be 1, X may be 2, X may be 3. So for all X, you add any like 0 to any value, the answer would be the same value. That is called as addition identity. Then commutative property of addition means X plus Y is equal to Y plus X. Then same thing how we can write, because we are taking two variables. So for all X comma Y, X plus Y is equal to Y plus X. Here this symbol is called as for all. It satisfies irrespective of any value of X and Y. And one more symbol in predicate is there exists, which satisfies to a particular value. Then we can use there exist. But if it is satisfied to all the values, then we can go for all. Okay, so this is the way we can represent the formulas using predicate logic. Then another formula is associative property of addition. Like if associative means we are taking three variables. So for all X, Y, Z, X plus Y plus Z is equal to X plus Y plus Z. And the basic operation like add. So instead of writing like this for all or for Y, we can use the proposition logic also, where the add is the function name or add is the symbol within bracket 2 comma 3, that is equal to 5. So 2 add 3. So 2 plus 3. Normally we used to write in mathematics 2 plus 3 is equal to 5. But in using proposition logic, we can write add, this is the proposition, 2 comma 3, that is equal to 5. So these are the formulas or the rules we can give to the machine to make the system intelligent or to be adaptable to this arithmetic operations environment. So store these rules in a structured knowledge base as the logical sentences, right? So all these rules we have to provide using either predicate logic or proposition logic to the system. Next, the second step is reasoning process. We have to build the reasoning capability also. It's not like we have taught to a student these are the formulas. We need to understand how a student, whether the student is understanding or not. Same thing, the same concept, the reasoning capability of the machine also needs to be developed by us. So the agent uses forward chaining mechanism to apply the rules and guide the students. Forward chaining means what? Suppose I'll give rules I have given and I'll give the inputs. Now I think you can find out the answer. This is called as forward chaining. If you get the result from the rules or from the facts, that is called as forward chaining. Reverse process, if you want to know the facts of the rules from the output, that is called as backward chaining. So one concept here I have used. The agent uses the forward chaining to apply the rules and guide the student. Like input is given by the student. Student gives a partial step, 2 plus 3 is equal to question mark is what? So what the agent means the machine, it searches the knowledge base for matching the rules. Is anything matching which we have already stored as per the previous rule? Yes, some one rule is matching here, and this one x plus y is equal to y plus a, even this one also it is matching, add 2 plus 3 is equal to 5. So it will, after receiving the input from the student, the machine will search this type of matching inside the knowledge base. If any match is found, then definitely it will provide the answer. So it uses the modern spawn if. That means A and A implies B, that is equal to B. That means what? If A union A implies B, that is equal to B only. That is equal to B only. So this type of inference rules are used and suggest the next logical step to the student. So this is what the reasoning mechanism happens by the agent. Then the third step is, in the second step, now I have given one example of inference. Student is giving, I need to simplify. I am a student, I want to simplify 2 plus 3 plus 4 because I do not know what is the answer of 2 plus 3 plus 4. Then if I give this question to the system, then the agent, how it will reason? So already we have fitted the associative rule. So agent will try to find out because this type of question, first it will try to find out the match with the knowledge base. If any rule is matching with this kind of statement, yes, some rules are there like the associative rule. Now let here x is 2 and y is 3 and z is 4. Now already we know that this rule already we have given, what is the rule? For all x, y, z, that means x plus y plus z, that is equal to x plus y plus z. Already I have given this rule to the machine. So whenever this match is found, so the left side part or the right side part, any part, it will try to find out. So 2 plus 3 plus 4. So it will find out the value of 2 plus 3 plus 4 first. It is 7. Then it will try to find out 2 plus 7, that is equal to 9. So this is the way the agent will try to solve the question by matching the statement with the fixed rules or which are already defined rules. Now while solving this kind of problem, sometimes what happens, some new things we used to add. Suppose here 2 plus 3 plus 4 I have written, instead of 2 plus 3 4, maybe same exact number it is not there in the system. So as this is a new problem to the machine will capture the answer and it will store inside the knowledge base. That is called as the updation of the knowledge inside the knowledge base. The third step is updating the knowledge base of student's input. If student makes correct progress, agent adds the new step to its knowledge base as the known fact. For example, student says 3 plus 4 is 7. So add 3 plus 4 is equal to 7. Now it is a new fact which will be added or which will be stored inside the knowledge base. Any new thing comes, it will be stored. If it is there already exists, next time it will not be repeated or it will not be redundant. So if the student makes, suppose student is doing any mistake, in that case what will happen? Sometimes by mistake we used to do the mistake. So agent applies the error detection rule. Student wrote suppose 3 plus 4 is equal to 8. In that case the machine will check or the agent will check against the knowledge base. But already it is stored there 3 plus 4 is 7. How come it is 8? Student is getting 8. That means 7 is not is equal to 8. So agent gives the hints that check your addition of 3 plus 4 again. So this type of messages we have seen in our system while performing any task. This is a simple example, just I am telling how the agent behaves against the user. If you are doing the correct action, it is well and good. If you are doing the wrong action, then in that case agent will give you or prompt you the action taken. Then the step 4 is dialogue and decision tree. The agent operates like a dialogue manager. It asks to clarify all the question, suggests steps based on the rules, remembers what the student already solved, and builds a reasoning tree of steps. So all these things are performed by the agent as well as it helps the student to learn arithmetic problems. So this is all about for this video lecture. I hope you might have understood how to design a logical agent, how to design the knowledge base of the logical agent, its reasoning process, as well as how it can update the knowledge of itself. So I hope you might have understood. So for the preparation of this video, I have referred this textbook, Soros Cosic for Artificial Intelligence. I have given the picture of the book for your reference. So till then, take care. Bye bye. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.